Greetings, fine people. My name is Leonard, and I am a junk crafter. In this episode, I want to feature an ongoing work in progress. Some years ago, the local community college was throwing out their old gym equipment. Since I can't resist scrap metal, I collected a large number of parts from the machines. For some time, I had been dreaming of building something, and now I finally had the materials to make it happen. I am proud to introduce the Scrap Hammer. What is a scrap hammer? The actual name for this type of machine is a trip hammer. A trip hammer is a simple machine that consists of a lever operated by some kind of power source which is connected to a hammer. The earliest trip hammers in recorded history were used for pounding grain and crushing stone, and were invented independently in the Mediterranean and China sometime around the first millennium BC. Initially, trip hammers were operated by hand or foot. Over time, water power, steam, and electric were used to drive the machine. The technology was later adapted for use in finery forges, which refined iron blooms into wrought iron and steel. Now, where was I? Ah yes, the scrap hammer. Someday I want to build a power hammer, which is a whole different topic that I won't get into right now. Maybe I'll do that in a future video. So, the scrap hammer. I'd like to give you a little tour, showing how it works and what I need to do to make it work better. I built a metal frame out of the gym equipment. Attached to this frame are a series of wheels and pulleys from bicycles and the gym kit, with drive belts connecting them, all driven by a 1-horsepower electric motor. I have to admit, I bought the drive belts new. I couldn't find any junk belts that were the right length. The hammer is a sledgehammer with the handle cut to fit the steel tube and strikes a railroad track anvil. The motor itself spins too fast for the final wheel. To reduce the speed, a larger wheel is attached to the belt at each step, with the following wheel being smaller. Reducing the speed of the belt also serves the purpose of increasing the amount of force imparted on the wheel. To keep the right tension on the belts, 3 bike inner tubes are connected at strategic points on the machine. If it seems weird, try it in place of a bungee cord sometime. They are also great for holding and clamping. Inner tubes are one of the greatest pieces of junk in existence. The belts drive the final wheel, which has a snail cam. The cam gradually pushes the hammer arm higher until dropping the arm and allowing gravity to do the work of hammering. So, what's wrong with this piece of junk? There are 5 principal issues. Issue number 1. Tensioner base moves when the treadle is engaged. Issue number 2. Pulleys are not aligned with the wheels. Issue number 3. Cam gear is made of plywood. Issue number 4. The anvil is not attached to the frame. Issue number 5. Hammer arm has too much play back and forth. As you can see, this piece of junk needs some upgrades. To start with, I'm going to tackle the tensioner. In the initial design, I put this heavy I-beam thing on the base to keep it from moving, thinking that it would be enough. Obviously, it wasn't, so that's going away. This piece of conduit was there to keep the other side of the tensioner down as it was lifting up too. We're not going to need that either. I figured the best way to keep these parts steady was to just weld a piece of metal between the base and the frame. Looks like it should work. Before welding, the frame needs to be ground clean. For the welder to work, it requires a path for the electricity to form the arc, and paint will interfere. I'm also grinding the metal rods, as the rust built up might make a poor connection. The welder I'm using is called a flux core welder. It is similar to a MIG welder, but does not have the inert gas component. Important safety tip. Always make sure that your welding mask is not set to the grind setting when you start to weld. Looking directly at a welding arc is a big no-no, as even mild exposure can cause permanent damage. In the short term, you can actually burn your cornea, which is like having sunburn on your eyeballs. I can tell you from experience that it's even less fun than it sounds. A couple of quick tack welds, and I'm ready to lay down a real bead. Another thing to make sure of is that you can reach the area you are working on easily. If you have to perform some kind of fancy gymnastics to reach the work area, then consider repositioning yourself or the workpiece. In other words, don't do this. On to the next brace. Again, we tack weld, make sure it's in the right place, and then lay down a solid bead. Moving on to issue 2, the alignment problem. First, we need to remove the axle, as the spacers have to be moved around to change the position of the wheels. Well, that was easier than it should have been. I've determined that the small wheels need to be closer to the other side, so I'll need a short spacer to keep them from rubbing against the frame. I'm using some copper pipe, as it's easy to cut and shape. After examining the wheels, I've decided that the rod connecting them to the big drive wheel is too flimsy. I'll replace it with a thicker rod that is also galvanized, which will prevent rusting. To make this the right shape, I'm heating it to bend the various angles needed to wrap around the hub and pass through the holes to the other wheel. The best way to get the exact shape you want is to use a mandrel, which is a tool you can wrap your piece around as a guide. I'm using a thick steel bar that also came from the gym. To fine-tune the shape, I'm giving it a few taps on the horn of my anvil-shaped object. If you haven't watched it, I have a whole video about this thing. After widening the holes and struggling with the fit, I've got the pulley wheel attached to the drive wheel. One minor thing I discovered. The connecting rod could rub up against the frame, and we're trying to remove problems, not add new ones. I found an old pizza wheel that I can use as a buffer. Now, I know what you're thinking. You're putting a razor-sharp spinning disc on this machine? Don't worry, I have other pizza wheels. It's not a waste of a circular blade. So now we position the wheel. Get the axle seated, drive the axle into position, and we're done. Great googly moogly. I forgot to put the drive belt on. Well, let's just skip ahead, shall we? Once the belts are on and the axle is in place, we need to keep the rod from slipping out. Ideally, it would be threaded and a bolt would hold it in place. I don't have that, so I'm fashioning a cotter pin instead. Everything is in place, so it's time for a quick test. Much improved. The cam gear is a fairly simple fix. Just replace it with a metal rod bent into the same shape. A minor thing I noticed was that the hub on the cam wheel was larger than the axle, so I'm replacing the rod with a thicker one. To do this, I need to drill out the holes a little. I made the shape at the club forge I belong to. The forges there are more powerful than mine, so it was easier to do it there. Once that was done, I brought the components into the workshop for assembly. These plates will hold the cam to the wheel and are an improvement over the plywood. Another safety tip. It's a good idea to clamp your workpiece when you use a drill press. If the bit bites into the metal and gets stuck, it tends to yank the piece out of your hand and then proceeds to smack it into your hand repeatedly. Don't ask me how I know. When drilling through thick plate, it's a good idea to cool your bit. I'm using WD-40 to do this, which isn't great, but it's better than nothing. After a few aggravating minutes, I managed to get through the plate. I think my half-inch bit might be getting old. To ensure that the other plate matches the first, I'm marking the holes rather than measuring on the new plate. I'd like to offer some more advice regarding drills. It is sometimes difficult to get the hole exactly where you want it, especially when drilling into hard materials, as the drill tends to wander around when you try to get the hole started. To make life easier, use a center punch to make a dent. This will act as a guide for the bit and stop the drill from wandering. I drilled out the other plate and then assembled the cam wheel. A quick test fit and everything looks good. On to the next issue. During my examination of the machine, I realized that I can actually fix two issues at once. I can fabricate two guides for the hammer arm, which will also serve to attach the machine to the anvil stand. That conduit pipe I removed earlier should do quite well here. Before I weld that into place, there is one other small issue that needs attention. As you can see, the rear of the frame is just sitting in the dirt. Assuming it didn't fall over, I probably would have buried half the machine over time if I kept using it. I'm going to put a plate under the legs to keep it from sinking further. Now the conduit brace. A few quick cuts, and it should be just the right size for fitting. Or they're way too long. Better than the alternative. A few more cuts and another test fit. I think it will actually fit more securely if I weld it to the face of the crossbar here and make the notch side on the anvil stand. This is the opposite of what I had planned, but the design allows me to change it without too much trouble. Some more cuts, and then it's finally ready to be welded. Here's another good thing to note. After welding, thin metals will tend to bend, altering how the piece is arranged. You can get around this by tack welding all the places welds will be, and then when you do your final welds, the parts won't move. Since I didn't do that here, I'm using an inner tube to force the braces into the correct position. I told you they're useful. A quick brush, and it's almost ready to go. While I've got everything out, I might as well secure the railroad track anvil. Inner tubes are not the answer to everything, it seems. At this point, the screen on my mask bit the dust and stopped dimming completely. It took a few seconds for me to realize it was happening, and I ended up getting a minor case of arc eye. I'd like to reiterate that it's not fun. With that done, time to test all of the fixes together. Here's the moment of truth. Huzzah! It works. And it works way better than before. Let's take a look at another angle. There's a bit of a wobble on the first drive wheel, but I don't think that it will be a problem. Oh dear God. Maybe increasing the tension? Okay, that's better. I think that the tensioner could be improved further, but you know what? I think it's good enough for now. Mr. Fine is displaying the final product of our labors. I still see many areas that could be upgraded, but the work done today was a vast improvement. I plan on using the scrap hammer in an upcoming video, so we'll look forward to that. Thank you for watching my video. If you liked it, please click the like button, leave a comment, and consider subscribing. If you didn't like it, please click the like button, leave a comment, and consider subscribing. Let me know what kind of projects you think I should work on. Until next time, stay crafty.